Hello students, I'm Imkong Tenlapungan from Department of Anthropology, University of Delhi. Today I'm going to speak on the module Mortality, Basic Concepts and Measures from the paper Demographic Anthropology. Well, the learning objectives of the modules are to understand the concepts of mortality, the definition of the terms used in mortality and the determinants of mortality, to describe, calculate, and interpret the mortality indicators. First of all, let us describe the basic concepts of mortality. Mortality is the incidence of deaths in a country's population. It is the continuous force of attrition that tends to reduce the population size. There are two fundamental differences between fertility and mortality situations prevailing in any country or society. Even in the remote past, when life depended on the whims of nature, death rate compared to birth rate was small. Since birth rate was nearly at its biological limit to keep the population growing, death rate needed to be curtailed. This was not easy against the uncertainty in supply of food and nutrition. Other factors that could keep the death rate down, such as proper shelter, technological know-how, and medicine needed to fight diseases and natural adversities, were at the rudimentary stage. Population in the past, it is believed, did not show any sign of steady growth for thousands of years. That the population in modern times is still growing in most countries is a proof that death rates in population are still decreasing. In the middle stages, death rates fluctuated in all the countries because of epidemic, famine or war. Secondly, fluctuation of death rate had generally remained small compared to birth rate. The mortality situation has steadily improved as the age of human civilization advanced. When the climate was good for agriculture, there was no shortage of food, no epidemic outbursts, and no war. Death rates declined. No more do we need to depend totally on the nature for our food. There has been a radical transformation in medical science and other technologies. Deaths due to frequent wars between countries have come down. Transport and communication network has improved remarkably to send medicines and other supplies to any ailing part of the world. There is some shelter for most people, which helps reduce exposure to natural calamities. There is no question of death rate shooting up suddenly. It is for this reason that we can fairly accurately predict the death rate for population in the next 5 or 10 years. But prediction of birth rate for a distant future has often failed. Death rate, unlike birth rate, responds quickly to the prevailing social and economic standards in the country. That the secular declining trend in mortality is more universal than decline in the fertility trend. That is why fertility rate as a single base is less reliable and effective than mortality in population projection. Now let us discuss the terminology used in mortality. According to the United Nations and the World Health Organization, death is the permanent disappearance of all evidence of life at any time after birth has taken place. It is the cessation of vital functions without capacity of resuscitation. Further, it is to be noted that there are different stages of mortality and different terminology used in differentiating the various stages of death. Following are some of the definitions which are based on the 9th revision of the International Classification of Diseases by WHO. Abortion, expulsion or extraction from the uterus of a non-viable product of conception before 8 completed weeks from day 1 of the last menstrual period. Miscarriage, loss of the product of conception at any time during the 8 to 12 weeks from day 1 of the last menstrual period. Next, we have the fetal death, death prior to the complete expulsion or extraction from its mother of a product of conception, irrespective of the duration of pregnancy. Next, we have stillbirth. If on completion of 37 weeks the fetus is born dead, it is considered to be a stillbirth. Perinatal mortality, the death of a life born within a few hours of birth. Neonatal death, death prior to completion of 1 month of live birth. Next, we have infant death, the death of a life born at any time from the moment of birth to the end of the first year of life. Next, we have the early childhood deaths, death up to 4 years of life. Death up to 9 years of life is known as late childhood death. Now let us see the determinants of mortality. The determinants of mortality include supply of food and nutrition, shelter, technological know-how, medicine needed to fight diseases, epidemic, famine, and war, as it is also shown from the above introduction. Neonatal mortality is substantially higher among deliveries attended by untrained personnel rather than those attended by trained health professionals, and the risk of infant mortality is lower for mothers of all age groups if they received proper antenatal care. The infant mortality deserves special attention in any study concerning mortality levels and indicators. It is so because the mortality in the early ages of life is more likely to influence the demographic structure of the society as compared to the mortality in the older ages. Now, in developing countries, increased rate of infant and child mortality is one of the major deterrents in the adoption of small family size norms. The theoretical link between infant and child mortality and fertility is that increase in the child survival chances facilitate a corresponding decline in the propensity to replace used by couples to ensure that they obtain desired family size. Social, economic, demographic, and environmental factors related to maternal and child health care are the known determinants of child mortality in general and infant mortality in particular. These determinants include ethnicity, parental education, place of residence, occupation and household income, age at marriage, sex and birth order of the child, maternal age at birth, birth interval, availability of adequate obstetrical facilities, and status of earlier siblings. Mortality has been found to have a significant association with socioeconomic development, programs aimed at controlling communicable diseases, health education, medical and health care, and improvements in sanitation. Now, there are several measures of mortality used by the demographer, in which some are simple and some are complex, some are direct and some are indirect. They are crude death rate, specific death rates, and standardized death rate. Apart from the crude death rate, the most commonly used measure among the demographic anthropologists are infant mortality rate and neonatal mortality rate. Now let us discuss crude death rate. Crude death rate is the most frequently used and most easily calculated index of mortality in a population. It gives a general picture of the mortality situation prevailing in the entire population. Crude death rate in a population or its segments often finds mention in all the informal reports dealing with population. Crude death rate, sometimes represented by M, is calculated by the formula crude death rate, or M, is equal to the given mathematical equation here, where D refers to the total number of deaths occurring to all segments of the population and from all causes within a geographical or social boundary and in the same time frame, usually a calendar year. Crude death rate not only gives us a broad picture of the mortality situation prevailing in a population, it also gives us a broad picture of the mortality situation prevailing in a population, and it also gives us a probabilistic statement of dying of an individual within the time period. Though very handy, crude death rate has several limitations. If we will refer to the definition of the rate of a vital event, assumes that the risk of dying for every individual in P is the same. This is an untenable assumption since the newly born babies, very young children, and aged people die in larger numbers than those in the middle-aged groups. A mining laborer has greater risk of life than a teacher or an office clerk. Women are more vulnerable in certain ages than men. There are considerable differences in death rates between regions and between communities and even among the educated and the illiterate people. For this reason, it is not desirable to compare death rates of two countries or two states or regions of the same country by the crude death rate. Crude death rate for India in 2000 was 8.5, a figure very similar to those in many developed countries. Yet India has an average expectancy of life of 63 years only, when most developed countries have expectation of life at birth well over 75 years. Whereas the developed countries have 20 or less infant mortality, India still had 68 infant mortality rate in 2000. That is, share of infants and young children in the deaths registered in a year is very high in India. In the developed countries, the old age group contributes more significantly in the total number of deaths registered. Crude death rate can reasonably well compare the death rates at two not very distant points of time of the same region for the reason that age and sex composition of the population generally do not change overnight. When the population is relatively large and there is fair amount of stability in economic, social and political front, the general composition of the population remains more or less at a stationary level. When crude death rates for several consecutive years are known, a general index for these years can be obtained by taking simple arithmetic mean of the crude death rates of those years. So here in this formula, if D1 refers to the number of those babies who died before attaining their first birthday and total number of babies who have not yet celebrated their first birthday, number of babies die out of number of babies who are between their first and second birthday, and so forth and so on, then are the death rates for the ages 1, 2, so on and so forth. In that case, crude death rate is calculated from the death rates at different ages in a population. Now let us see specific death rates. Crude death rate speaks of the average mortality rate in the general population, but mortality rates vary between ages, between male and female, between urban and rural people, between various occupational groups, and etc. So, crude death rate gives the mortality picture in a population at a glance, but does not say if person in some specific group in the population have the same probability of dying as in the total population. Specific death rate, that is denoted by SDR, provides answers to this question. Generally, the population is classified into different segments by age, sex, residence, religion, occupation, and other social and economic characteristics. We can compute mortality rate for all these segments separately. Specific death rate is a ratio of the number of deaths in a specified segment in a specified space and time frame to the mid-year size of this segment in the said space and time frame multiplied by 1000. Specific death rate, therefore, is a crude death rate of a specific segment of the population. The most widely used specific death rates are sex and age-specific death rates. This is the number of deaths recorded for persons in the ages X and X plus N-1 last birthday. The mid-year population for this group is, then age-specific death rate is defined as ASDR equal to the given equation here. Now when N equals to 1, that is the last birthday is X, a person dies within X and X plus 1 years, the ASDR becomes annual age-specific death rate and is given by this equation. When calculating ASDR for females in the numerator would refer to the number of female deaths, and in the numerator would be for females in that particular age. For non-annual ASDR, the symbolic relation would be as in the equation 2. When both age and sex-specific death rates are calculated, the following samples are used. as given in equation 5. Superscript f or small f is to be replaced by m or m when age-specific death rate for males is to be estimated. If we wish to calculate age-specific death rate of urban females, the symbolic presentation of ASDR would be as given in this equation, that is equation 6. With specific death rates, comparison between two population groups becomes more meaningful. Crude death rate for males in India was 8.9 against 8.1 of females in 2000. For getting an answer to the question why there was such a large difference, we may look for clues in sex-specific ASDR. SRS data show that IMRS for male and female babies are almost the same, around 71, but between age 1 and 3, the death rate among female babies is 1.5 times as large as that of the male babies. Female death rates continue to be higher till about the age of 24 years. Thereafter, the male death rate overtakes female death rates. By the time age 50 is reached, male death rate is 1.64 times higher than that of the female death rate. That is, from 25 years onwards, the probability of a woman dying is much smaller than that of a man, and this continues till the end of either's career. But even with lower death rates after the 25th year, the losses of life experienced in the early years, especially in the age group of 1 to 3 years, could not be compensated by higher survival rates at higher ages. That is why sex ratio in the population in India continues against women. We can compute cause-specific death rate as other specific death rates are calculated. We have to classify deaths according to cause of death. The subscript X in equation 4 would refer to cause of death rather than age at death, though both can be combined to give age-specific death rate for a particular cause. The denominator remains the same and refers to the population group for which causes of mortality were to be indexed. An illustration for calculation of ASDR is given in this table, Table 1. Estimation of age-specific death rate is really difficult unless we know accurately the age of the deceased. We have to rely on the age reported by the doctor in his death certificate. Errors are bound to creep in measures of ASDR. We do not have such a problem with the crude death rate. Life tables cannot be constructed without the accurate knowledge of age and sex-specific death rates. Although age and sex-specific death rates are the most wanted death statistics, ASDRs are not without limitations. Though ASDRs are more scientific and practical and they can successfully be used for year-by-year comparison of two or more populations of different types, no unified picture about the mortality in a population can be had from ASDR. For this, we have to fall back on CDR or some such other measure. Standardized death rate. We have seen that ASDR do not tell us if population A has larger or smaller mortality rate compared to that of population B. One can compare two populations for their mortality level only if we could calculate some sort of an average taking into consideration the variability in different segments of the populations. The simplest such measure is CDR. Now, CDR is in fact the combined average of the age-specific death rates in a population. If we have that the average mortality for different age groups, the composite mean from this means is given by this equation, that is equation 7, where P equals to and T equals to, let this and represent CDR for the populations A and B by equation 7, we can write this equation. Now, the 1999 population has been estimated using compound interest law, taking 1991 population as the base year population. The average annual growth was taken as 1.95%. Percentage of age group population to total populations is that for the year 2000. It is assumed that age distribution for the year 2000 is also valid for the year 1999. Column 4 is the SRS estimated percentage of deaths in each age group. crude death rate for 1999 is assumed to be the same as that for the year 2000, that is 8.5. 8.5 multiplied by 98492851 estimated 1991 is assumed to be the same as that for the year 2000, that is recorded in 1999 to 2000. This is the sum of total deaths in the population. The multiplied proportion of deaths in age group, column 4, gives estimated number of deaths in each age group. ASTR then is calculated by the usual formula. The column totals for estimated values do not agree with the numbers we had started with. The minor difference can be attributed to the approximate values for various proportions. The estimated ASTR closely agree with SRS data for 2000 except in the last two groups. Even if the two CDRs have the same value, we cannot say that age-specific death rates of the two populations are similar. Implicit in the statement is the fact that the relation of similarity will hold only if we have this equality. Now, it is also a fact that equal specific death rates of all age groups in the two populations do not lead to the conclusion and would be identical only if the variable weights assigned to ASTRS of both the populations are the same, and that is the ratio are similar. This can happen only if the age distribution of two populations is identical. Our experience is that no two countries or two segments of a population display identical age distribution in the population. The solutions to comparability of general mortality rate in two or more population is obtained if we could use identical weights for ascertaining ASTRS for the population we are trying to compare. Since the weight assigned to mortality rate of a specific age group in a population is different from that in the other population, we can use the weights observed in a third population to both population A and B. This third population is called the ideal or the standard population S. With this standardization, new average death rates can be worked out, and accordingly we have this equation, that is equation 8. This age-adjusted new crude death rate is referred to as standardized death rate, STDR. The selection of the standard population in calculation of STDR is vital. STDR will be heavily dependent upon the age composition in the standard population. Two different standards would invariably produce different results when we intend to compare the death rates for different regions or states. The age distribution of the whole country would be an ideal one to substitute the observed age distribution of the states or the regions. However, one must ensure that the substituted distribution is not radically different from the distribution which it substitutes. Ideally, life table stationary population distribution of the standard population is best in computing the STDR. The method we have discussed just now is a direct method for estimation of STDR for each of the population, including the standard one, the age-specific death rate, and the number of persons in each age group or their proportions in the total must be known. There would be many instances where CDR and age distribution are known but not the ASTR. The method followed for estimation of STDR in such a situation is referred to as the indirect method. Indirect method estimation, however, ASTR for the standard population must be known. Suppose if we have this as the ASTR in the standard population, and also suppose that ASTR in the standard population A is also known, we can compute four different types of average death rate: CDR of population A, STTR of population A, STDR of population S, taking population A as the standard, CDR of population S. If we closely look at the four computed average death rates, an approximate relation could be established between those four, that is B into C equals to D. We can find out a close approximate value of STDR for population A from this. B equals to the given equation here, that is STDR of A equal to CDR of A. The ratios within parentheses in equation 9 are the adjustment factors. There are computation procedures both by indirect and direct method. SRS data for 2000 has been used to compare the general mortality rates in West Bengal and Tamil Nadu. The standard population begins in India since 2000. Now converted into STDR, the difference in the general mortality rates in West Bengal and Tamil Nadu get reduced considerably for about 1 point prior to standardization to only 0.16 after standardization by the direct method and 0.37 when standardization is done by the indirect method. Now let us see infant mortality rate. It is defined as the number of deaths under the age of 1 year per 1,000 live births for the year. In demography, infants are defined as an exact age group, namely age 0 or those children in the first year of life who have not yet reached age 1. And it is important in the analysis of mortality because infant deaths account for a substantial number of deaths, especially in those countries where health conditions are poor. Infant mortality is one of the most frequently calculated measures of mortality. This measure is often used as an indicator for the purposes of ascertaining the levels of economic development and general levels of health among a population. Infant mortality rate is equal to this equation, that is equation 10, neonatal mortality rate. Mortality during the neonatal period is considered a good indicator of both maternal and newborn health care. Neonatal mortality rate is thus equal to, as given in equation 11. Based on the theoretical importance, the explanatory variables influencing mortality at the neonatal and early childhood age are organized as follows: maternal and biodemographic factors. This includes maternal education, age of the mother at giving birth, birth order of the child, birth interval, mother's body mass index, sex of the child, and weight of the children at birth. Secondly, we have health services utilization factors, for example, full antenatal care, tetanus vaccination, place of delivery, and assistance at the delivery. Next, we have household environmental factors. We have toilet facility, water facility, electricity, exposure to mass media, etc. Fourthly, we have socioeconomic and regional variables, for example, standard of living, caste, place of residence, and region. Now let us summarize what we have learned in this module. Mortality is one of the factors that influence the statistic of any population apart from affecting the health of the population on an individual basis. Study of mortality has become very significant for analyzing the current demographic conditions. It also reveals the population's health conditions. There are different stages of mortality and different terminology used in differentiating the various stages of death. The term includes abortion, miscarriage, fetal death, stillbirth, perinatal mortality, neonatal death, infant death, early childhood death, and the childhood death. The determinants of mortality include supply of food and nutrition, shelter, technological know-how, medicine needed to fight diseases, epidemic, famine, and war. Social, economic, demographic, and environmental factors related to maternal and child health care are the known determinants of child mortality in general and infant mortality in particular. These determinants include ethnicity, parental education, place of residence, occupation and household income, age at marriage, sex and birth order of the child, maternal age at birth, birth interval, and availability of adequate obstetrical facilities and status of earlier siblings. There are several measures of mortality used by the demographer in which some are simple and some are complex, some are direct and some are indirect. There are crude death rate, specific death rate, and standardized death rate. Apart from the crude death rate, the most commonly used measure among the anthropological demographers are infant mortality rate and neonatal mortality rate. That's all for this module. Thank you so much.